Laws of Exponents. Here are all the laws of exponents that you should know and have memorized. When you search online, you will see a long list of math equations that look like this. I suggest that you review this video in full and come back every now and then to memorize this list, because each equation is extremely important in guiding you to solve problems that look like this, or even this. If you're interested in me making a video like that, feel free to let me know in the comment section. Let's start with a simple case. X to the power of 1. This rule simply means anything to the first power will give you the value itself. So if we have the expression x to the power of 1, we will get x as the final answer. If we have a different variable like t to the power of 1, we will get t. If we have 68 to the power of 1, we will get 68. If we have a goldfish to the power of 1, we will get that goldfish, because anything to the power of 1 will get you that value. The next laws of exponents say anything to the power of 0 will give you 1. So if we do x to the power of 0, we will get 1. If we have a variable m to the power of 0, we will get 1. If we have an expression like 2 times x plus 5 times the square root of 525 and all that divided by 4 times x plus x times y and all of that raised to the power of 0, we will get the value 1, because anything to the power of 0 will get you 1. The next law on the list of exponents is x to the power of negative m, where m is just a placeholder for any value. X to the power of negative m is simply equal to the inverse of x to the power of m. Or in other words, this is simply 1 divided by x to the power of a positive m. So for an example, let's say we have x to the power of negative 4. This is the same thing as saying 1 divided by x to the power of 4, or 1 divided by x times x times x times x. Because since we have a power of 4 here, this x to the power of 4 means that x is being multiplied together 4 times. If we wanted to, we can expand the variables like that, which can come in handy when simplifying expressions. The next law on the list of exponents is x to the power of m to the power of n. This law basically states that we can raise something to the power and raise that result to a power of n to get a result of x to the power of m times n. It's always best to work with an example, so here's the next example. Here we have x to the power of 3, which is in parenthesis to the power of 4. When we have this form, we can multiply the exponents to get a value of x to the power of 12. Let's talk about why this is true. When we have x to the power of 3 and the exponent of 4 is on the outside, this is the same thing as saying x to the power of 3 times x to the power of 3 times x to the power of 3 times x to the power of 3. If we simplify these variables, we will get a total number of 12 x's, which if you multiply this together, you will get x to the power of 12. This also works with negative exponents as well. Let's say we have x to the power of 7, and let's put that to the power of negative 2. This is the same thing as saying x to the power of negative 14, because when it's written this way, we can multiply both exponents. The exponents in this case will give you a negative number, because a positive number times a negative number will give you a negative number. So in this case, we have x to the power of negative 14. Another way we can write this is 1 divided by x to the power of 14. We can write it this way based on the previous law of exponents that I mentioned. If we simplify this expression, we can do 1 divided by x to the power of 7 and multiply these twice, since the exponent on the outside have a 2 on the outside. When we simply even further, we will have 7 x's here and another 7. 7 plus 7 is 14. So therefore, again, the answer is 1 over x to the power of 14. The next law on our list states that if we have a base of x with an exponent of m, and this is being multiplied by the same base to the power of n, then we can add the exponents together. For an example, if we have x to the power of 4 times x to the power of 2, then we will get a value of x to the power of 6. Let's talk about why that is so. If we focus on x to the power of 4, x is being multiplied together 4 times. But if we focus on x to the power of 2, this is being multiplied twice. So therefore 4 plus 2 is equal to 6. Let's take a look at this problem. 3 times x to the power of 3 times x to the power of negative 7 times x to the power of 0. We know from our laws of exponents that x to the power of 0 simplifies to 1. So now we are left with 3 times x to the power of 3 times x to the power of negative 7. So in this problem, since we have the same base, we will add up the exponents and get a final value of 3 times x to the power of negative 4. Let's see why this is the answer. If we apply one of the laws of exponents for x to the power of negative 7, the 1 over positive x to the power of positive 7 will be multiplied to the 3x to the power of 3. When we multiply this together, the 3 and x to the power of 3 will end up being in the numerator. Here x is being multiplied 3 times in the numerator and x is being multiplied 7 times in the denominator. At this point, we will cancel x's. What you do to the numerator, you will need to do for the denominator, and vice versa. So that means that if I cancel out 3 x's in the numerator, then I will need to cancel 3 x's in the denominator. Once we simplify this, we will have 3 times 1 over x to the power of 4, which we can rewrite as 3 times x to the power of negative 4 because of this exponent law here. Let's change this up a bit. Let's say we have 3 times y to the power of 3 times x to the power of negative 7 times x to the power of 0 that we need to simplify. Again, based on the exponent property, x to the 0 power becomes 1. Now ask yourself, do we need to simplify this problem even further? Well, no, since the x and y have different bases, we cannot add the exponents together. So therefore, the answer to this problem is 3 times y to the power of 3 times x to the power of negative 7. Let's take a look at the next law of exponents. Let's take a look at x to the power of m divided by x to the power of n, which is can rewritten as x to the power of m minus n. It's always best to work with an example. So let's say we have x to the power of 5 over x to the power of 4. If we subtract 4 from 5, we are left with x to the power of 1, or just simply x, which is based on the property I gave earlier. Let's say that we expanded the x's in the numerator and denominator. What we do to the numerator, we need to do to the denominator and vice versa. So the goal here is to simplify this expression. So we will cross out 4 x's at the bottom and 4 x's at the top. Then we will get a final answer of x to the power of 1, or just simply x. Let's take a look at this next problem. X to the power of negative 3 over x to the power of negative 5. When we subtract negative 5 from negative 3, we get a positive 2. So therefore, the answer is x to the power of 2. Let's say we didn't remember this law. What we can do is try to expand the x's as best as we can. In the numerator, we can rewrite x to the power of 3 as 1 over x to the power of a positive 3, and then at the denominator, we can rewrite as 1 over x to the power of 5. One thing we can do is if we are dividing fractions, the fraction that is in the denominator, we can take that fraction and switch the numerator with the denominator like so. Then we can multiply that result by this numerator and we will get x to the power of 5 over x to the power of 3. Then we can simply this expression and get x to the power of 2, which is the answer. If you need further help with that, let me know in the comment section. Let's take a look at the next law of exponents. X over y to the power of m is equal to x to the power of m over y to the power of m. This basically means that we can distribute the m to the numerator and denominator. Let's take this example. Let's take 8 over 9 to the power of 2. When you take 8 to the power of 2, you get 64, and 9 to the power of 2, you get 81. So therefore, the answer is 64 over 81. Let's take a look at the last law of exponents, x times y to the power of m. This means that we can distribute the m to different bases. Let's say we have a base of t and c to the power of 5. When we distribute the 5, we will get t to the power of 5 times c to the power of 5. Thanks, y'all, for taking the time to watch this video. If you guys have any questions pertaining to the video or would like to share anything else, feel free to leave it in the comment section. Also, if you found any value in this video, definitely feel free to like, share, and subscribe. Be safe, y'all.